Welcome, this is Black Lotus, your YouTube script kiddie, and today I'll be going over Pandas-NoSql, a Python library that adds read, write, and append functionality to the Python package Pandas. Pandas-NoSql supports Mongodb, Elasticsearch, Redis, and apache-cassandra. For those 4 NoSQL databases, it'll add read capabilities. For MongoDB, Elastic, and Redis, it'll add write capabilities, and for apache-cassandra, it will provide append capabilities. To show its functionality, I'll start up a REPL. I'll import pandas as PD, and I'll import pandas-NoSql. Okay, and on my computer I have random data, so I will read that in. Okay, and this data has a bunch of random columns. It's in the form of a data frame, and it has strings, ints, floats, booleans, and date-times. So the first NoSQL database I will be showing off is MongoDB, and just to let everybody know, I have 4 servers running in the background, 1 for each respective NoSQL database. The host for each one will be localhost. So to send this data frame to Mongo, I use the toMongo method. And I need to provide a database, which I will call randomDB, and I need to provide a collection, so I'll call this one random collection. And to show that that one actually went through correctly, I'll go ahead and create a second data frame called MongoDB, and I will read in the data using pd.readMongo. And readMongo takes in the same arguments as the toMongo. So if I look at the MongoDB, I have all my original columns plus the ID that MongoDB creates. And if I look at the dtypes, the toMongo method will preserve all the correct dtypes. The next one is Elasticsearch. Once again, I'll use df in the to method. This time it'll be toElastic. Elasticsearch needs, instead of just one host, it'll ask for the argument host, and host can either be a string or a list of strings. So in this case, I would just provide a string. It also needs a username, in this case the default on my computer, and a password, again the default when I installed Elasticsearch. Okay, and it'll ask for an index to create. And then I'll pass the create index argument as true. Get a bunch of warnings because it's using verified certs equals false. But it does go through. And to show that it goes through, I'll create yet another data frame. This one I'll call Elastic Data Frame, or Elastic DF. And it'll be read Elastic. Actually, before I do that, I'm going to create a variable called Elastic Fields. And this is just going to be a tuple of my columns. And this will make sense in a moment. Now I'll go ahead and create that data frame. So elastic df, pd.readElastic. I'll give it the host again. And in my case, it'll just be a string. We'll give it the username, the password, and then the index. This time I'll also add another parameter called fields, and this will be equal to the fields that I specified. And we'll read that in, and we'll take a look at it. So read elastic will give you the index, the ID, and the source as a bunch of dictionaries. If you want to flatten that out, then the read elastic has one more parameter. It's called normalize. And we'll set that equal to true. And now when we see our elastic data frame, we get the columns plus the index and ID. One thing to note about the elastic data frame when using pd.readElastic is that almost all of the data types are preserved except for date types. They are converted to Python objects, in this case strings. Okay, so moving on, we will send our data frame to Redis. Redis will take in a host name, once again localhost, the port, at this it'll be the default port 6379, and then a Redis key. To show that it once again worked, we'll make our data frame Redis df pd.readRedis, and it'll take in the same arguments. And we can see our data frame once again, and that all the data types are preserved. One additional parameter you might want to add for the toRedis method is an expiration time. So expire. Let's take a look. df toRedis. It'll be expire seconds. We'll set it equal to 10 seconds. And then if I can do this quick enough, we'll say df2 equals, and we got it in time. And then if we continue to wait out the rest of the 10 seconds, it will eventually throw an error. And now the data frame has been purged from Redis. If you don't put expire seconds, it'll just persist. And finally, the last one will be Cassandra, apache-cassandra. Cassandra is a bit different than the other ones, as it doesn't add write capabilities, it simply adds append capabilities. So you must have both a key space and a table already created within your Cassandra environment. I set one up before recording, so for this I will call toCassandra to upload it into the table that I have already created with the specific data types for that table. We'll need to provide contact points. Contact points must be a list of strings, even if it's just one for localhost. The port is the default port for me. The key space I have is random data, and the table I created is called random table. And to show that it actually went through properly, once again, I will create one last data frame, in this case pd.readCassandra, and it'll take the same arguments as the toCassandra. And once again, this is an append. The toCassandra was an append, not a write. And when I read the Cassandra data frame, There's my data frame once again, and there are the D types. They are correctly preserved. This has been a quick tutorial for Pandas-NoSql. Thank you for watching, and I hope you got something out of it.